Zoona and I'm going to be talking about the simple train that I made with just 3 materials: a AAA battery, neodymium magnets, and copper wire. On both sides of the AAA battery, there are 2 neodymium magnets attached to it. Once they're put into the coil that was wound up, the magnet and the battery together, they moved in motion. So here you can use a simple fact that if you have 3 variables: electricity, movement, magnetism. So if 2 of these 3 variables are present, then the 3rd variable will be produced. So in my case, I have magnetism and electricity in order to create movement within the wire. So some background information on this. Basically, if you run a current through a wire, as in this picture, it generates a magnetic field. When a magnet is moved into a coil of a wire, like my contraption, a voltage will be generated in a coil, according to Faraday's law. For example, when a magnet is moved into a solenoid or a wrapped coil, the galvanometer responds to that increasing field. The induced magnetic field inside any loop of a wire will always act to keep the magnetic flux in the loop constantly. So in my train, that front it's pulling with attraction, and in the back it's pushing with repulsion. My electric train can connect to the maglev train. They use superconductors, which is wires that are cooled down to a really cool temperature, and those superconducting coils can actually levitate another magnet. So out of the train is all magnet, and the track are supercooled wires. That train levitates. Like my train, the magnetic fields pull the train from the front and push it from the back. So thanks for watching, and I hope you learned a lot more about my simple electric train that I created. If you want to see more experiments and see how they work and the physics behind them, check it out.
Cut.